In this example, we are going to try to find, let R be the region bounded by the graph of this quadratic and the x-axis. So we're going to find the volume generated when R is revolved around the y-axis. So if I am doing the y-axis, then I'm going to need to put everything into terms of y, which this is not exactly ideal to try to turn this into terms of y. So how do we solve for x when we can't even combine those like terms? So there is another option, and that is us doing finding volume by shells. So finding the volume by shells is, we have a different formula for that. So it's going to be 2 pi x times f of x times dx. And so that comes from finding the area of all these shells, that when we unroll these shells, that length right there, that width is going to come from circumference. And circumference is a 2 pi r kind of a formula. Our r is going to be the x distance out. So there's 2 pi r. And then we have to have a height to it. So that's the area, the base of that prism. So then this is your width times your height. And then we have a thickness essentially to it. So we can leave everything in terms of x. We just got to plug in stuff and figure out what we got going on. Let's figure out our bounds, all that sort of stuff. So let's do the visual of what does that look like. And so just before I begin any of it, let's do a little math, a little algebra. Take in this x minus x squared, and we set it equal to 0. If we factor an x out, we'd have a 1 minus x equals 0. So x would equal 0 and x would equal 1. Those are our x-intercepts of a parabola that's facing down. So rough sketch, we have x-intercepts at 0 and 1. The graph is doing something like that. But we are rotating it around the y-axis. So we're going to take this and rotate it around. So it's going to be kind of a, I don't know, a flat donut looking thing. So normally we would turn everything into terms of y because we're rotating around the y-axis, but if we use shell, we don't have to do that. We can leave everything in terms of x. Our bounds are going to be 0 to 1. So our volume is 0 to 1, 2 pi x. Our f of x is our equation, our y equals. And so I can replace that with x minus x squared dx. So let's take the pi out, maybe even take the 2 out. We don't need to use those, why not? And then we'll distribute the x in, so that'll be an x squared minus x cubed. And we are going to do the antiderivative of that. So antiderivative of that is we're going to add a power. So x cubed divided by 3 minus x to the 4th divided by 4. And we're going to go from 0 to 1. So let's plug in 1. If you plug in 1, you're looking at a third minus a 4th, and then minus plugging in a 0. Those would all go away, so just a minus 0. And a third minus a 4th, we need some common denominators. So we have a 2 pi that eventually is going to multiply into, let's see, this is going to be a 4/12 minus 3/12. So 2 pi times 1/12. And if we multiply that, 6 and 1, pi over 6 is our volume. All right, so that was using the shell method. Rather than, since we're rotating around the y-axis, rather than turning everything into terms of y, let's leave it. We just have to take a different approach to it.